Okay, and we're back. Okay, so what we want to do next is go over section 4.2. And section 4.2 is really about um, coming up, using a truth table to come up with a combinational algebraic function. Okay, and so let's have a look at a truth table, and then let's really start drawing the relationships of how we go from a truth table to an algebraic expression. Okay, so let's get into this spreadsheet document here, and let's pretend we have, excuse me, 3 bits. Okay, so what we have is A, B, and C. Okay, and then what we have is a function f, which is the output. And so in a 3-bit system, let's go ahead and align this with all the possible combinations of values these bits can take. Okay. Alright. So this is 3. This is 4. Okay. This is 5. Oops, this is 6. Okay. Alright. And that is 7. Okay. So for all the possible values of Boolean values of A, B, and C, we go ahead and draw the inputs for those. Okay. So let's go ahead and center this. Okay. Let's format. Okay, I'm trying to find the center button. Okay. All right. Okay, good. Let's go ahead and center this. Okay, excellent. Okay. So what you're seeing here is all the possible values for these 3 bits. Okay. And so suppose what we have here is f is going to be equal to 1 if and only if it's greater than, if it's equal to 3 or greater. Okay. And it's 1, it's 0 otherwise. Okay. So the word problem here would be something on the order of, could be modeled to be something like this. F is equal to 1 if and only if n is greater than or equal to 0, 0, 0, 1, 1, base 2. Okay? So what we have here is a representation that's helping us come up with the f function, okay, given these sets of inputs for A, B, and C. Okay, so far so good. This is a truth table similar to ones that you've seen so far. Okay, so what we'll want to do here is come up with an algebraic equation for f. Okay, and let me actually do that over here so you guys can see this more clearly. Okay, f is equal to, all right, so under what conditions is f equal to 1? Well, it turns out the first time that that's true is when a is 0, which could be represented as a prime, and where b and c are true. Okay, or it could be the case that it could be this case where a is true, b is false, and c is false. Okay, and the b, c being false are going to be represented by their primes. Or it's true when what's that third one? When A and C are true, but B is false, okay? So A, B, inverse C, or okay, when A, B are true, C is false. Or if A, B, C are all true. Okay. All right. So this should be hopefully pretty straightforward how we went from this truth table to this algebraic equation. And so, great. So what we have here is a relationship between the truth table and the expression. Okay. So one of the things that you'll notice is that this is step 1. Okay. If you go back here, all right, composing the truth table is step 1. Finding the switching function that represents that behavior is step 2. Okay. So for the sake of simplicity, since we spent plenty of time on this, I wanted to simplify this specification. So I gave it to you here in the form of, actually let me make sure this is big, because depending on the resolution of the video, this may or may not be big enough. So, okay. Hopefully that's pretty clear. Okay, so we simplified, okay, the word problem to just this, because we spent plenty of time talking about the word problem in the first video. And really what I wanted to do here was show you step 1 and 2, which is after you've got the truth table, you can come up with the algebraic function. Okay? So hopefully there aren't any more, hopefully that's pretty clear. And then, you know, are we done at this point? Right? That's what you should really ask yourself is, are we done? Right? And so if you look back at this algorithm, the one that we came up with in the first lecture, okay, we said, well, great, we want you to come up with a switching function. Now that we have that, what we want to do is we want to simplify. We're not done until step 3 is done. So let's go back here and let's try to simplify this, okay? Let me copy and paste this here, so we'll work this out, okay? All right. Okay. So what can we notice here? Okay. It looks like the first terms could be combined using the uniting theorem, right? And then the A prime could be eliminated using the elimination theorem. Okay. So what we can have is, all right, let's go back here. Okay, this is going to be A prime BC ORed with AB prime ORed with AB. Okay, all right. And so if you have any questions, all right, about how we got this, let's go ahead and work it out, just in case. Okay. All right. So let's go ahead and work this out. A prime BC. Okay, just you simply copy it down because there is no further simplification you can do on that. Notice here, okay, notice what you have here, okay. What you could do is you could factor out AB prime, and you're left with C prime or with C, okay, ORed with AB, okay, factored out C prime or C, okay. And using the elimination theorem, we know that this is equal to A prime BC simply comes down, AB prime, ORed with a 1, right? So anything ORed with its inverse is going to equal to 1. ORed with, okay, AB, okay, ended with C prime ORed with C, which is 1, okay? And so finally, what we could do is anything ended with 1, okay, is going to be itself. And that's what you see here. So hopefully this kind of shows you, oh, and I'm sorry, we're not done. We can take this a step further, right? What we can do here is take this a step further. Okay, you can factor out an A, in which case you'll get a B prime B, okay, all right, which will equal to A prime BC, or with A, okay, all right, okay, all right. So I trust that you're able to follow what I'm doing so far, and I'm simply just applying the theorems that you learned in chapter 3 to simplify this expression that we came up with in step 2. And so that's all this is really. It's just simplifying all this. Okay. And so we can take this a step further, okay, and finish this simplification with A ORed with BC. Okay. So hopefully that shows you how to go through, starting with a word problem, going to a truth table, coming up with an algebraic expression, and then ultimately simplifying the algebraic expression down to its simplest form, and which can then just be easily represented with an A wire with B and C ANDed together. Okay. So that should be pretty straightforward. Okay. So, as you may have noticed, when we first started this problem, we said, hey, wouldn't it be interesting if we were to try to come up with an algebraic expression for the things that are represented by a 1, right? So, for the function f, right, let's come up with an algebraic expression, okay, for the terms that yield a 1 for the function. But that was just sort of arbitrary, right? We could have easily chosen to do that for the terms that resulted in a 0. So let's go ahead and do that. Okay. So I'm just simply going to rearrange some stuff here, and you'll be able to follow along. Okay, great. There we are. Okay. So if we were to do that for, right, so part 1 of this was, hey, wouldn't it be interesting if we were to come up with an algebraic expression for f? Well, what about f prime, right? Well, we can certainly put some time and figure out what that algebraic expression will look like. And let's go ahead and do that next. Okay. So if someone wants to help me here, what is the truth table for f prime going to look like? Anybody? Oh, good. All right, here we go. Yeah, that's right. So you go to 1, 1, 1, 0, 0, 0, 0. Okay. That's what f prime would look like. Okay. So what we want to do, okay, is actually, for the sake of argument, you really didn't need to come up with f prime here. All I was trying to illustrate is if we were basically coming up with an expression for the 1s, we should ultimately be able to come up with an expression for the 0s. And so let's go ahead and do that. When is f 0? When a, b, c, okay, are all 0s. They're all false, right? And so if you look at the combinations, okay, it's pretty much going to be, all right, when the combinations have the values of 0, 0, 0, 0, 0, 1, and 0, 1, 0, okay, then f is going to equal to 0. Okay? And so let's go ahead and do that. Okay, let's go ahead and do that. All right. So what we could do here is, all right, and we'll go over this in a bit, but for now, let's go ahead and fill this out. Okay, so f is going to equal to 0 if and only if a or b or c, okay, are going to be ended with two other terms, a or b or c prime, right? Right? Okay. And then ended with a or b prime c. Okay. Let's go ahead and make this a little bit wider so you can see. Okay. All right. Okay. So yeah. So basically, in the case of a ORed with b ORed with c prime, that's 0. Only for the combination 0, 0, 1, and a ORed with b prime ORed with c is only 0 for combination 0, 1, 0. Okay. All right. So yeah. So what we have here, okay, is we have a function that represents the possibility when f is 0. Okay. That's all that this is trying to show you. Okay. All right. And so similarly, you're able to use the distributive law, right, to simplify this a little bit further. Okay. And we'll go ahead and write that in here so you can see how you get that. Okay. Oops. Okay. All right. So what we could do here is this is going to come down to this. Okay. Which is going to equal to this. Okay. ORed with BC. Okay. All right. So, okay. So what we want to do here is we want to have a way to be able to write f prime, okay, after this step, as a sum of products. Okay. That's what we want to be able to do. Okay. So the thing I'm getting to is the following. Okay. A minterm expansion, okay, is a product of, let's go back to this so we can get us, okay, let me go back here and let's write on this. Okay. So a minterm expansion, a minterm, let's just say that, okay, is a product term in which all the variables appear exactly once, either complemented or uncomplemented. Okay. And so this is going to be in the form of a sum of products. Okay. So if you look at this, all right, let's look at the definition and see that this is true. Okay. So minterm is a product term in which all the variables appear exactly once, either complemented or uncomplemented. And this is represented, okay, canonically as a sum of products. And there's an example of this here, right? As we work through it, this is an example of a minterm expansion for this function f. Okay? And so these are denoted by small letter m. Okay? So you know, let's see if we can, let me see if there's a better way I can, here, I think there is a better way to represent this. Let me think of what's the best way. Yeah, let me go ahead and start another sheet so I can show you this more clearly. Actually, I can probably do it here since, yeah, we can do it here. Oh, that's interesting. Why did that? Okay, let's go to another sheet. Do the okay. So if I were to write the min-term here, let me make this bigger so you can see. Okay. All right, and let's just do min-term number, right? So this is going to be an M0, M1, M2, M3, 4, M5, and M7. Okay, and the min-terms here are going to be A prime, B prime, C prime, right? This basically represents 0 for A, 0 for B, 0 for C. This represents A prime, B prime, C, represents 0, 0, 1. Okay, 1, 0, sorry, 0, 0, 2, 0, 1, 1 is represented as A prime, B, C. Okay. All right. Let's see. Actually, A prime, B, C. Prime, C prime, right? This is 2. 3 is represented as A prime, B, C. 4 is represented by A, B prime, right? C prime, since it's 1, 0, 0. 5 is going to be represented as A, B prime, C, because it's 1, 0, 1, right? And then 6 is going to be represented by A, B, C prime. And 7 is going to be represented by, oops, A, B, C. Okay. All right, there you go. Okay. So, and you know, the codes for this, it's really straightforward, but let's just write them down. Is 0, 0, 1. Oh, okay, great. Okay, so this isn't going to work. Let me see if we can change the format here. Anyway, I think you get it. Basically, it's, these are the min-term codes, right? And the letter that corresponds with them is itself or its complement, depending if it's a 1 or 0. Okay. So hopefully that's pretty straightforward. Okay. So yeah, so basically this is the min-terms of 3 variables, right? It's represented by a small letter m. This integer here, the m6, the m5, these are all subscripts. So when you go ahead and write them, I want you to write them as subscripts. But just kind of remember that when we're talking about min-terms, we're talking about lowercase m. We're not talking about uppercase m. Okay? And so yeah, so if we go back here, okay, if we look at the min-terms for 3, 4, and 5, it's going to be these, right? So let's copy and paste these in here. Okay. All right. So alternatively, okay, these could be represented with this, right? That was weird. Why didn't I copy over? Okay, there it is. Okay. So you could see here the min-terms are represented by these. These are the min-terms, right? A prime, B, C. And this is the min-term number, which corresponds to a 1 for the function where f is equal to 1 in that case. Okay. So anyway, this is sort of the notation for min-terms. Okay. So this f function here may as well has been written by M3 or with M4 or with M5 or with M6 or with M7. Okay, that is the minterm expansion of this function. Okay. All right. So this is going to be the minterm list form. Okay. So we're simply just listing what the minterms are. Okay. All right. Sounds good. So yeah. So for f, just to recap, wherever f is equal to 1, we have minterms. Here's the number. Sorry, here are the minterms. Here's the minterm number. And we can simply write it in this following way. Okay? So hopefully that's pretty straightforward. It allows you to see where the midterms are. Okay? Great. So what are max terms? Okay? A max term is a sum term. Sorry, I got this cold, so I'm starting to fight a cold. Is a sum term in which all the variables appear exactly once, either complemented or uncomplemented. Okay? Alright. So, if we were to go back to this sheet, alright, okay, the max terms here, okay, are going to be A or B or C. Let's write that without a space so we can write this a little bit quicker. Okay. And 0, 0, 1 is going to be represented by C prime, right? Okay. 0, 1, 0 is going to be A ORed with B prime, ORed with C, 0, 1, 0. Okay. Alright. 0, 1, 1 is going to be A ORed with B prime, ORed with C prime. Okay. 1, 0, 0 is going to be A prime ORed with B, ORed with C, A prime ORed with B, ORed with B, okay, C prime, okay, and then 1, 1, 0 is going to be 1, ORed with 1, ORed with C, which is equal to 0, and A prime ORed with B prime ORed with C prime is going to represent 7. And what we want to do here is the max terms are going to be represented by capital M's. Okay. All right. So notice what happened here. These are max term, and this is the max term number. Okay. Oops. Okay. So for the previous problem, right, the max term expressions, okay, in turn with respect to ABC, oops, right, would equal, okay, M0, okay, oh sorry, we need to do a summation symbol here. So what's the best way to do that here? Since I don't have the scientific package installed to do scientific notation, I'm going to put that here for the summation. Actually, maybe it's better that I do... No, that doesn't work. 1, 1? No. Well, what it is, it's the notation, mathematical notation for sum. Okay. 0, 1, and 2. Okay. So that is going to be representing the max term list form. Okay. And so what we'll see here is that a min term, okay, so going back to this, a min term is basically going to be a product term, and a max term is going to be a sum term. Okay, so a min term is a product term, and max term is, okay, a sum term. Okay, so let's go back to what else we want to cover here. Okay, all right. So yeah, so this sheet here basically gives you an idea of how, if you had n variables, okay, each one of them will assume zeros and ones, and according to that, we're going to have midterms and max terms. And the midterms are going to follow this small letter, they're going to be represented with a small letter m. The max terms are going to be represented with a capital M. And the relationship between the Boolean variables a, b, and c follow the following format. Okay. So again, you got the midterms here and the max terms here. Okay. All right. So when a function f is written as a sum of its midterms, then we can say that that's a midterm expansion. Okay. It's a sum of products. Okay. So if f is equal to 1 for any of the rows in the truth table, then small letter m, okay, must be present in the expansion. Okay. All right. And so just like I showed over here, okay, this is going to be the midterm expansion, okay, for function f. Okay. All right. So, and when a function f is written as a product of its max terms, okay, then we call that the max term expansion. Okay. And so this right here is an example of a max term expansion. Okay. And so I think the thing we'll want to do is kind of work through an example of this, as you'll see, to kind of make it more clear. Okay. So let's go ahead and do that, just to be able to kind of set in your mind what the relationship is here between these. Okay. So let's go ahead and work out a problem. Okay. Let's create another sheet for this. Zoom in. Okay. So suppose we wanted to find the midterm expansion of f of a, b, c, and d, which is equal to a prime, b prime, or d, ORed with ac, d prime. Okay, suppose we are looking to find the midterm expansion of this. Okay, all right. So, given what you know about this, you're pretty much confident that the answer needs to look, right, as something like this. So the first steps here, okay, is to distribute, well, first let's write this function here and then start doing some work on it. Okay, so one thing we'll want to do here real quick right off the bat is, is distribute the a prime, b prime. Okay. All right. So what we have here is we have a prime, b prime, ORed with a prime, d, ORed with ac, d prime. Okay. Hopefully that makes sense. Now, what we'll want to do here is introduce, okay, the missing terms. So if you were to look at A prime, B prime, what is the missing term? Okay. The missing term, or the missing variable, is C. Okay. And it's also D. Okay. Why is it C and D? Well, we'll go over that in a sec. Okay. All right. Well, think about it. If we have a function expressed in terms of A, B, C, and D, and we only see A and B, then we need to introduce C and D. Those are the missing variables. Now, if you notice, we can do this because the output of C ORed with its prime is equal to 1, and 1 ANDed with anything is itself. Okay. And we can also introduce the D ORed with D prime because we know that that's equivalent to a 1. Okay. So let's go ahead and do that for the rest of the terms. So what we have here is A prime D. Okay. Let's see if this is going to work. And the term we're missing here is B and B prime. And we're also missing a C and C prime. Okay. All right. And then ACD prime is missing a B and a B prime. Okay. All right. So how are we doing so far? The point of this problem is to find the midterm expansion of a function in terms of A, B, C, and D. We go through and introduce equivalencies of the missing terms. So in the case of AB, we're missing C and D. We introduce C ORed with its complement because we know that that's equal to 0. Okay. So let's keep going. Okay. So if you really start to, multiply this out, you're going to end up with something like A prime, B prime, C prime, D prime. Okay. ORed with A prime, B prime, C prime, D. ORed with A prime, B prime, C, D prime. ORed with A prime, B prime, C, D. ORed with A prime, B prime, C prime, D. ORed with A prime, B prime, C, D. ORed with A prime, B, C prime, D. ORed with A prime, B, C, D. With A, B, C, D prime. ORed with A, B prime, C, D. Okay. D prime. Okay, that was a mouthful. Okay. Very good. Okay, so far, all we've really done is introduce missing variables and multiply it out. Okay. And so you could see that we have a duplicate term. We have a duplicate term of A prime, B prime, C prime, D. Right? Here it is. Let's go ahead and do this so you can see more clearly. Okay. All right. So we have So what we have here is we know that x ORed with x, right? Anything ORed with itself is equal to itself. Okay. So having said that, we can cross out A prime, B prime, C prime, D, this one, with A prime, B prime, C, D. Okay. All right. Because those are the duplicate terms. Okay. So these two are duplicates, and that's why we can get rid of them. Okay. So is that okay? You guys can see A prime, B prime, C prime, D. A prime, B prime, C prime, D. Okay. All right. And then you have A prime, B prime, C, D, which is right here. A prime, B prime, C, D. Okay. So we can cross these two out. So if you cross those two out, okay, what do you end up getting? Well, let's go ahead and write that out. You get A prime, B prime, C prime, D prime. Well, here's what I'm going to do. Well, that's all right. Let's just write this out. Okay. ORed with A prime, B prime, C prime, D, ORed with A prime, B prime, C, D prime, ORed with A prime, B prime, C, D, ORed with A prime, B, C prime, D, ORed with A prime, B, C, D, ORed with A, B, C, D prime, ORed with A, B prime, C, D prime. Okay. Alright, sounds good. So if we were to, right, that's a very trivial thing. All we did was we got rid of duplicates. Okay, there were duplicates, we just got rid of them. Because anything ORed with itself is itself, right? X ORed with X is equal to X. Okay, alright, sounds good. So we can get rid of those duplicate terms. So what's another way of, let's see, what's another way of, right, what does A prime, B prime, C prime, D prime mean? Well, it simply means A, B, C, and D are zeros. What does A prime, B prime, C prime, D mean? Well, it means everything's a zero except for the D. Okay? ORed with A prime, B prime, C, D prime, which means it's 0, 0, 1, 0. Okay? And what's A prime, B prime, C, D? Well, it's got to be Z, 0, 1, 1. Okay? ORed with 0, 1, 1, 1. ORed with 1, 1, 1, 0. ORed with 1, 0, 1, 0. Okay? Alright? So let's see if that makes sense. Okay? All I'm doing here is going to the previous line. If A is A prime, then it's represented by a 0. If it's just A, then it's represented by a 1. Same thing for the other variables, and that's what you get. So really, the midterm expansion here is the summation, mathematical summation term for m of, well, m of 0, 1, 2, 3, 5, 7, 10, and 14. Okay, so we get 0, 1, 3, 2, 3, 5, 7, 10, and 14. Okay. All right. So, just to be clear, right, you can go back to this to confirm, right? Okay. The midterm expansion is going to have the duplicates as well. Okay. So, again, if you just go through this line and you figure out what midterm numbers they are, it will come out to that. Okay. Okay. Sounds good. So what about, this is the midterm expansion. What about the max term? Okay. What about the max term expansion? What does that look like? How do we get that? Well, truth is, it's simply its inverse, right? So let's add a row below. Okay. So if the min terms are those, the max terms are going to be the product of everything else. So as you guessed it, we have 4 variables, 16 possible combinations. Anything that's not in the min term is going to be in the max term, because those two have an inverse relationship. Okay, if you want to look at that, there's an explanation in your book. Okay. All right. So yeah, so what we did here is we basically said, the problem was, how do we find the midterm expansion, right, of a particular function? Well, you introduce the missing variables, okay, and we introduce them with the following theorem, because we know that anything ordered with itself is going to be equal, with its prime is going to be equal to 1. Okay. So what if, right, we wanted to find another way? So the way we basically computed come up with a max term expansion here is we basically took anything that wasn't in the min term as its max term. Okay, and so if you can see, again, back to this chart, notice that everything at min term is simply the max term of its is a midterm product of sums okay, is the sum of products, max term, right? That's the relationship. So in here, what you see is all the variables are inversed, and instead of a product, they're summed. Okay, so that is the relationship between minterms and max terms. So you can, by having one, you can easily get the other. But suppose, what you had to do was you need to find another way to find the max term expansion. How would you do that? Well, we sort of already had, right? So suppose this thing said, find the max term expansion of this function. Okay. Well, what you would do is something very similar, but instead of adding, instead of, here, let me show you what I mean, so you can get an idea of this. Okay. All right, let's see. What do we want to do next here? PD. Okay. All right, let's see. All right, I'm just thinking of what part do I want to show you here. Okay. So, so let's go ahead and continue working this problem, and then we'll talk about the rest later. Okay, so an alternate way of basically finding this max term, okay, is to factor out f, okay, to obtain a product of sums. Introduce the missing variables in each term, okay, using x ANDed with x prime is going to equal to 0, okay. So just like for the minterms we used x ORed with x prime is equal to 1, here we're using this theorem that x ANDed with x prime is going to be equal to 0. Okay, anything ANDed with its inverse is going to equal to 0. Okay, so in this case, what we have is a prime, b prime, or d, ordered raised to d prime. Okay, let me add some more rows here. Okay, let's add a couple more. Sounds good. Okay. So then what this is going to turn out to is it's going to be a prime ORed with cd prime. Notice we want to do a product of sums here, okay? Or with a or b prime or d, okay? All right. And so what we're going to do here is we're going to be introducing the missing variables, okay? And actually we're going to do that in the next step. So let's go ahead and simplify this a little bit more, and then I'll show you what I mean. Oops. It's kind of challenging doing this with spreadsheets. Or C with A prime, ORed with D prime, ORed with A or B prime, or with D. Okay. Alright. So then what we're going to do here is we're going to introduce the missing variables. Okay. In this case it was B, right? B was the missing variable. So we'll introduce that. And then B also happens, B and C are the missing variables in the second group, right? So in this group, the B was the missing variable, right? In this group, C and D, okay, are the missing variable. I'm sorry. The D, okay. So in this first group, B and D are the missing variables. In the second group, B and C are the missing variables. In the third group, C is the missing variable, okay? So here we go. Let's go ahead and work this out. we have A prime ORed with the missing B's, ORed with C, let's see, C prime, D prime, right? D prime, so it need to be C, C prime, right? Okay, and that last one, let me just write this down so we can concentrate. C, C prime, ORed with D, okay? So that should be, right? So all we did was introduce the missing variable, okay? And then if you take this out a little bit further, okay, what's going to happen is you'll notice, well here, let's go ahead and do it so you can see the duplicate. Okay. All right, let's keep going. Okay, so, oops. All right. Okay. All right, so what we're going to do here is we introduce the missing variables, okay? So let's keep going. A prime ORed with B, B prime, ORed with C, ORed with D, okay? All right. And what we're going to have here is going to be A prime ORed with BB prime, ORed with C, ORed with D prime. Oops. And then what we have here is going to be A prime ORed with BB prime, ORed with C, ORed with D prime. Okay. Oops, yeah. Alright. Now we're going to have A prime ORed with BB prime, ORed with C prime, ORed with D prime. And then finally we're going to have A ORed with B prime, ORed with C prime, ORed with D. Okay. Alright, and you'll notice that A prime, B, B prime, ORed with C, ORed with D prime is redundant. So you can cross that out. So what you'll end up getting here is going to be A prime, okay, ORed with B, ORed with C, ORed with D, okay, A prime, ORed with B prime, ORed with C, ORed with D, okay, and then we're going to have A prime, ORed with B, ORed with C, ORed with C, D prime, then we're going to have finally A prime, ORed with B prime, ORed with C, ORed with D prime, okay. And another way of saying this is 1, 0, 0, 0, 0, right? So in the case of max terms, the A prime is equal to 1, and a B, a C, and a D is equal to 0. Because if you notice, the relationship between F and F prime, okay, then the relationship between those is that of an inverse. Okay. So, anyway, what this comes out to is, how did that get in here? It's weird. Okay. So what this comes out to is 1, 0, 1, 1. Okay. Okay, and the second term is 1, 1, 1, 0, 1, 1, 0, 0, and 0, 1, 1, 0 is the last one. Okay. So this corresponds to this. And again, the way we got this was to introduce the missing variables. One of these was redundant, so we got rid of it. And really, the maximum expansion here would be M of, okay, 4, 6, 8, 9, 11, 12, 13, and 15. Okay. Sorry, I think I skipped some lines here. Okay, so, yeah, we need to keep going. Kind of did this. or with B, or with C prime, or with D prime. Oops. Again, if this feels a little tedious, it's because it is. But you just kind of work this out so you can see. Okay. Then you get or B prime, C, or D. Okay. You get or B prime, C prime, D. Okay. Alright. So anyway, when you do that, you'll see that okay, let's see. It's that's right. It's 1 0 0 0. Okay. 1 1 0 0. 1 0 0 1. Okay, good. So let's do that. 1 0 0 0 0 0 0 1 1 1 0 1. Okay. Alright. And the rest of this follows. Yeah, so I just skipped ahead on my notes from the book. But basically, yeah, so what we want to do here is we want to basically find the maximum expression. The way we did that is by introducing the missing variables according to the theorem that anything ORed with its inverse is equal to 0. So we can safely OR it with the existing f of ABCD function. And that's what we did. We found the maximum expressions using, after we introduced that, and we're done. We write the max term expansion form. So anyway, now you see how you can get from midterm expansion to maxterm expansion. Again, real quick thing here is to just simply, the max terms are the things that aren't the midterms, right? And so you can either use this theorem to, you can either use that theorem to find the maximum expansion by introducing the missing variables, or you can use this, right? So, okay, all right, okay. So, given that these two are true, right, you can basically introduce missing variables and find the expansion, okay? So hopefully that was pretty understandable. Basically, it's just a little bit tedious, but you have to kind of see it. Again, the midterm expansion is basically, all the variables appear exactly once and they're a product term. The max terms are, it's a sum term, right? So you can see the terms are summed. Here you can see the terms are products. Okay. And let's see, is there anything else we want to say about this? Yeah, so I think, generally speaking, that's what the relationship between the midterms and maximums is. Thanks.